Hi, in this video, I will be showing you problem number 30 of the practice exam 1 which covers chapter 1, 2 and 3. Solve the system. 2x plus y plus 2z equal to negative 2, negative 2x plus 2y minus z equal to negative 5, 4x plus y plus 2z equal to 0. We'll call these three equations as 1, 2 and 3. So usually in these problems, we'll use addition or elimination method, meaning that we will be making the coefficients equal and opposite. If they are not already like that, then we will add or subtract, whatever the case may be. Now in this equations, we see equation 1 and equation 2 have the same coefficients equal and opposite for x, 2x and negative 2x. So we'll take those two equations and simply add them. So I'm going to say add equations 1 and 2. So it is 2x plus y plus 2z equal to negative 2. Negative 2x plus 2y minus z equal to negative 5. When you add them, you get 0x plus 3y, because these two cancel out, 3y plus z equal to negative 7. Because this is missing in x, we'll call this new equation as equation 4. Then we will take definitely equation 3, because we have not used it yet, along with either equation 1 or equation 2, and then we'll eliminate the same variable x, because the first one that we got, equation 4, is missing in x, so we have to get another equation which is again missing in x, missing the variable x. So now we are going to take equation 3 and equation 2. So it is negative 2x plus 2y minus z equal to negative 5, and 4x plus y plus 2z equal to 0. In order to make the equation, the coefficients of x equal and opposite, we have to multiply the first equation or equation 2 by 2. When you have to multiply, make sure to multiply both sides of the equation by 2. So you get negative 4x, if you distribute, negative 4x, positive 4y minus 2z equal to negative 5 times 2, that is negative 10. We'll just call it equation 2 again, because it is only equation 2 rewritten differently. And then this is 4x, equation 3 is 4x plus y plus 2z equal to 0. Now we are going to add equation 2 and equation 3. That way we can eliminate the variable x. So add equation 2 and 3. So these two get subtracted, these two get added, and that will give you 0x, and 4y plus y, that will give us 5y. 2z minus 2z, these two cancel out, negative 10 plus 0, which is negative 10. And then if you divide both sides by 5, you get y equal to negative 2. So we already found y equal to negative 2. Now we will take another equation which involves only two variables, and then we will substitute y equal to negative 2 into that equation. So if you see, if you see equation number 4, it involves y and z. So substitute the value that you got, y equal to negative 2, in equation 4. So it is 3y plus z equal to negative 7. So 3 times y gets replaced by negative 2. So we get negative 6 plus z equal to negative 7. So if you move the negative 6 to the other side, z will be equal to negative 7 plus 6, which will be negative 1. Negative 6 on the left hand side becomes positive 6 on the right hand side. So get one more value of the variable, which is z equal to negative 1. So we got y, we got z. Now we have to get only the value of the variable x. So we will choose any of the three equations is okay. We'll choose equation 1 in this case, which involves x, y, z, and we'll plug in the value of y and value of z into equation 1, and then we'll solve for the variable x. So substitute y equal to negative 2 and z equal to negative 1 in equation 1. So it is 2 times x plus y. Y can be replaced by negative 2, and then plus 2z. Z can be replaced by negative 1 equal to negative 2. I am considering equation 1. So I have substituted the value of y, the value of z. So it is 2x minus 2 equal to negative 2, or 2x minus 4 equal to negative 2, or 2x, if you move the negative 4 to the other side, it becomes positive 4. Negative 2 plus positive 4 equal to positive 2. So you get 2x equal to 2. Divide both sides by 2. That will give us x equals 1. So now the solution to the problem is the values of all the variables. So x equal to 1, y equal to negative 2, and z equal to negative 1. You can also write this as an ordered triple. So it's 1, negative 2, negative 1. That is the solution to the problem. Hope this video helps.